So what happens in a quick sorting procedure is I pick up a pivot element. Initially in this quick sort procedure, I pick up the last element as my pivot element. So what I do is I pick up 12 and I start comparing. So if 100 is greater than 12, then I swap the two. I just keep whatever I am doing is I am segregating two arrays जिससे कि 12 से छोटे वाले come in the first part, 12 से बड़े वाले come in the next part, and 12 is now at the correct position. So the new array that will come out to be, since 100 is greater, 100 will be here. 1 is smaller, 50 is greater, 50 will be here. 1 is smaller, 1 is here, 3 is smaller, 3 is here. 8 is smaller than 12, 70 is greater than 12, 80 is greater than 12, 5 is smaller. So that this is the array which is smaller than the pivot element, smaller than equal to, and this is an array which is greater than the pivot element. I repeat the same procedure on both the halves. अब ये half हो ये जरूरी नहीं है. Now here I pick up 5 as the pilot. Again इस particular array का last I position 5. 1 छोटा है, 3 छोटा है, 8 बड़ा है. I will be again calling quick sort on 1, 3 and 8. 8 is one element, no need to sort. 1 and 3 में 3 के against sort करेंगे, it is sorted. So this becomes my sorted. Again I pick the pivot element which is 80 here. 80 से छोटा, 100 is greater, 100 comes after. 50 is smaller, 70 is smaller, this position is fixed. Now recall quick sort on this and this half. So what am I doing? I am partitioning the original array according to the pivot element. The first half, the left part of the partition is smaller than equal to the pivot element or the key element or whatever you call. The right half is greater than that element. And this is, I recursively call the procedure again and again and again. This is how I achieve quick sort. I hope easy and simple to understand. You all understood what am I doing? How am I doing it step by step? Let us look at the algorithm and then I will repeat each and every step. The concept is to partition the array into two halves and again into two halves such that whatever pivot element I am picking, left half is smaller than equal to the element, right half is greater. So I am calling quick sort. I am creating a procedure for quick sort where I have a beginning से लेके end तक I am calling the procedure. Now for the quick sort, again since it has to be a recursive call, so first condition of any recursive function is you should begin with breaking the recursion. So breaking the recursion is if beginning is not less than end. So I have to check if beginning is less than end, only then do the procedure, otherwise don't do the procedure. Then only I will be doing this procedure. If the array beginning is not less than end, that means array is having a size either a single element or a zero element. Single element है तो भी sort करने की जरूरत नहीं है, zero element है तो you cannot sort. So if beginning is less than end, only then do the sorting, otherwise don't do the sorting. Then I am taking some q to be the partition. So I partition this. I will be calling another function partition. I will just define on a from beginning to end. And I am now calling quick sort again on the left half according to the partition, right half according to the partition. Partition call होने के बाद क्या होगा? My array would have been partitioned q से छोटे in the left, q से बड़े in the right half of the array. So I again call quick sort on the left half, which is from a beginning to q. This is the left half of the array, and I am again calling quick sort on a q plus 1 से लेकर end तक. I am again calling it here. Now this is all. quick sort में बस इतना ही procedure है. That's it. A is the array जिस पे sorting करनी है. A is the array on which we are. Pivot element की position जो है वो q है. अभी वो कैसे select करें वो मैंने नहीं दिखाया है. Q is the position of the pivot element. Q is not the pivot element. Q is the position of the pivot element, जिससे लेफ्ट में आपने लेफ्ट हाफ पे दोबारा क्विक सॉर्ट कॉल करा है और राइट पे राइट हाफ पे दोबारा क्विक सॉर्ट कॉल करा है. So let me give you the partition and I will do the dry run once again. So what is there in partition procedure? I have to partition A from beginning to end according to the pivot which I am picking to be the last of the array. So this is my partition procedure which I am defining. In this I am picking some x to be the last element. Okay, this is A of end, last element, and I am picking I to be beginning minus 1. From here I am beginning. Now I am running a loop for j is running from beginning to end minus 1. Last element तो हमने pivot pick कर ही लिया है. So I am running the loop from beginning to end minus 1. Do if A of j is less than the last element, which is x. If it is less than the pivot element, then I is I plus 1 and I exchange A of I with A of j. I will rerun the procedure. Don't worry, just write it down first. After the loop is over, you will see that we have done the partitioning. Now I have to reinsert x back into the correct position. So the correct position of x would be exchange A of I plus 1 with A of end, or you can say x to be the largest element. This is all in the partition procedure. Let us see an example and again let us try to dry run the procedure. The same procedure we will be dry running using the example. Let us see how. So I am having a list, supposedly 36, 15, 40, 1, 60, 20. I'm just taking a random list. So you can take any list. I'll begin, since I want a bigger list, I'm beginning from here. I have a 36, 15, 40, 1, 60, 20, 55, 25, 50 and 20. Supposedly this is the list. And how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 elements are there in the list. Okay. We have called quick sort from 1 till 10. Initially quick sort call हुई है 1 से लेके 10 तक के लिए. Initial quick sort has been called from the beginning to the end. What will happen? I check whether the beginning is less than end. 1 is less than 10. Yes, 1 is less than 10 is true. 1 less than 10 is true. What I do? I call partition. So I go to the partition part. Let us come here. X is A of n. That means X is this 20. This is now X. Okay. I is beginning minus 1. So I is 1 minus 1, which is 0. J is initially beginning, which is 1. And I have to run this loop from 1 to 9. Beginning से end minus 1 तक this loop is running. What I have to do is I have to check A of j less than x. That is the last element. Okay. So A of j, currently A of 1 is 36. So I am checking 36 less than 20. No, it is not less than 20. Do nothing. Go to the next iteration of the loop. Increment j. I increment नहीं हुआ है, j increment हुआ है. So I अभी 0 है. This is j. 36 less than 20. No. Increment j comes here. Again check 15 less than 20. Yes, 15 is less than 20. Condition is true. So when the condition is true, increment I. सबसे पहले तो I को first पे लाओ. Increment I and swap I and j. Exchange ai and aj. So that 36 comes here, 15 comes here. ये समझ आया? Or if you want me to write it separately, this was 36, this was 15. These are swapped so that 15 comes here and 36 comes here. Right? Rest of the array still remains the same. Again rerun the procedure. J comes here. I यहीं पे ही है. 40 less than 20, no. Do nothing. J increments. Now 1 less than 20, yes. Increment I. I comes here now. अब ध्यान रखो पहले वाले जो भी लोकेशन है वहां पे हमने छोटा एलिमेंट डाल दिया. अब नेक्स्ट बड़े पे आ रहा है I. Swap I and J. So what happens? I is this location. So you swap these two. So that 1 comes here and 36 comes here. So I am swapping I and J. 1 comes here, 36 comes here. So if I rewrite in the same, it becomes more easier to you all. So that now I have 15 here. यहाँ पे 36 था उसकी जगह 1 आ गया and this becomes 36. Next iteration, J changes 60 less than 20. No, do nothing. J changes less than equal to कर देना. 20 less than equal to 20. Yes. Increment I. I comes here. Swap I and J. So that 20 comes here. 40 comes here. Again increment J. 55 less than 20. No. 25 less than 20. No. 50 less than 20. No. Loop over. 1 से 9 तक ही जाना था ना. 50 less than 20 तक चेक होगा. फिर you will come out. Now exchange A of I plus 1 with A of end. A of I is currently this. So exchange this with the last. So that the new array which you are now going to get is 20 comes here. And here you have 36. So that what has happened, if you see, try to understand is this part of the partition. ये हमारा Q की location है. Q. You have to return I plus 1 also from here. I am missing that. Kindly return Q की position क्या होगी? Return I plus 1. So इसके बाद एक line लिख लेना, return I plus 1. So what is returned is 4. That is the position of Q. Now left half of the array are having elements less than 20. Right half are having elements greater than 20. That means the left half of the array now is 15, 1, 20. Then I have 20 and then I have 60, 40, 55, 25, 50 and 36. These are the elements greater than 20. I will again be calling quick sort. Now I come back here partition के बाद 4 है यहाँ पे. A से beginning से लेके 4 तक I again do the same thing. Sorry, make it Q minus 1. 4 तो we have taken as the partition ना. Partition Q has been sorted. उसको नहीं देखना. अब इसे sort करना है और इसे sort करना है. Now here it comes out to be 20 again. I will be picking up 20. It is again called partition. This time beginning is 1, end is 3. 4 minus 1 is 3. Right? So I am calling it for 4 minus 1, which is 3. Again, I starts with 0, J starts with 1. X this time is equal to again 20 because this element happens to be 20. We are having repeated elements. Again, the loop is running from 1 to end 3 minus 1, which is 2. A of J, which is initially 1, 15 less than 20, yes. If it is less than 20, I have to exchange A of I and A of J. Technically, I भी यही है, J भी यही है. I increment होके 1 पे ही आएगा. So exchange 15 with 15, it remains here. Go. Again, J becomes here. It is also less. Exchange J with J. It remains here. After the partition position is here and this remains the array 15 and 1. Right hand पे कोई array ही नहीं है, left पे ही है. Again partition will be called from 15 to 1 and again Q से left पे call होगा, Q से right पे तो कुछ array ही नहीं बचा, so it will not be called. After calling 1 will be picked. 1 will be picked. Since 15 is greater than 1, nothing will happen. You will be exchanging. Loop खत्म होने के बाद you will just be exchanging the position. So 1 comes here, 15 comes here. So this is how this will be sorted. Then you will call quick sort on the next half. And the same procedure would repeat. Are you all now understanding how quick sort is happening? Yes, class? Everybody, is it clear? J तो लूप वेरिएबल है ना, अपने आप इंक्रीमेंट होगा हर आइट्रेशन ऑफ द लूप में. I तभी इंक्रीज होगा जब हमने स्वैपिंग करा है. पहले I को इंक्रीज करेंगे तब स्वैप करेंगे. J is increased every time the loop is getting continued. Loop variable है J. Clear? Let us have a look at the complexity of the algorithm now. Now let us have a look at the complexity. Now what is happening is, this is my quicksort procedure. This is the partition and quicksort is happening called for 2 times. So if I am calculating T of n, this comes out to be whatever time partition is taking. How much time is partition taking? Maximum n times single loop hai. Of the order n time is the complexity of partitioning. It is a single loop which is running with constant statements. So the complexity of this partition procedure is of the order n. For this loop, there is no other loop or nothing else here. Other than partition, I have 2 calls to the same function. Now, calls कैसे हो रही हैं? So this is something happening. Tn is getting broken into 2 calls. एक तो of the order n हो रहा है partition में. Plus, if I am breaking into almost half, supposedly it is the best case. Best case में या average case में, I will be breaking the array into almost 2 halves so that it will be broken into n by 2 and n by 2. Then it will be broken in n by 4 and n by 4, n by 4 and n by 4 and so on. So that the recurrence relation will come out to be 2t n by 2 plus of the order n. This will be my recurrence relation. Now, if this is the recurrence relation, then the complexity would come out to be of the order n log n. Using the Master's theorem or any other theorem? Yes, class? The complexity would come out to be of the order n log n. But this is only the best and average case for quicksort algorithm. What happens in the worst case? Let us try to see. Is this clear? Best and average case clear to all? Complexity. Worst case में क्या होगा? जो आपका array है, that will be, that is going to be sorted such as कि यहाँ पे जो एलिमेंट लिया है वो लार्जेस्ट ही था पूरी लिस्ट में, तो n-1 एलिमेंट्स पे दोबारा आपको क्विक सॉर्ट करना पड़ गया. अब सपोजिटली ये स्मॉलेस्ट है या लार्जेस्ट है, तो यू हैव टू अगेन कॉल क्विक सॉर्ट n-2 एलिमेंट्स, सो दैट व्हाट इज हैपनिंग इज n/2 में बाइफरकेट होने की जगह it is getting bifurcated in 1 n-1, then 1 n-2 every time. It is getting bifurcated worst case में ऐसे. So what will be the height of the tree in the worst case? Worst case ऐसे समझ लो, आपकी जो लिस्ट है that is 3, that is 10, 8, 6, 4, 1. Supposedly this is my worst case. I pick 1. 1 comes here. 10, 8, 6, 4. n-1 के लिए दोबारा क्विक सॉर्ट कॉल हुआ. 4 is the next pivot picked up. 4 comes here. 10, 8, 6 के लिए फिर से कॉल हुआ. 6 comes here. 10 और 8 के लिए फिर से कॉल हुआ. 8 comes here. Then it is again and so on. So what is happening is, कितनी iterations लग गई? 1, 2, 3, 4, 5 एलिमेंट्स को सॉर्ट करने के लिए 5 टाइम्स को सॉर्ट को कॉल करना पड़ गया. So the height of the tree in this case becomes n. So that the equation is not this anymore. Here Tn becomes 1 plus T of n-1 multiplied by some constant whatever is there. And multiplied by and plus partition का time तो लगेगा ही, तो plus of the order n still remains. So when I am having this, you will be doing a substitution method or iterative method. Tn-1 plus T. तो On को कितनी बार ऐड करना पड़ेगा On से? N times, so that this becomes n into On, that is of the order n square. So the worst case complexity of quicksort also comes out to be of the order n square. ये क्लियर हुआ सबको? If we are bifurcating, the partitioning is happening into 1 and n minus 1, yeah, even 2 or almost n minus 2. So the number of times the recursion is happening is almost n times, and every time on time is taken for partitioning. So since n times recursion is multiplied by on, so the complexity comes out to be of the order n square. Is it clear to all the worst case complexity of quicksort?